Hey Audrey, so here is the first problem that you needed some help with. So here's what we want to do. We want to first step convert everything to improper fractions because that is the way we can factor things out and reduce, and it makes life a lot easier. We can deal with smaller numbers that way. So first of all, 4 times 3 is 12 plus 1. That's going to be 13 over 4, and that's over p. And then 2 times 6 is 12, plus 1 is 13, over 6. If you hear something in the background, some crunching, that's my stupid dog, and I don't know what he's eating. What are you eating? I don't know what, he's got something that he's crunching on, but he's very loud. 10 times 3 is 30 plus 2, so that's 32 over 10. So before I move on and do anything else, I want to see if there's any fractions that I can reduce now that they are improper fractions. Whenever you have that opportunity to reduce fractions, it's a good idea to do that because then you're dealing with smaller numbers that are easier to just do in your head, right? So you can see the answer more readily. So this can't reduce at all because 13 is a prime number, and this won't reduce, but this one will. I can divide both of these by 2, and that's going to give me 16 over 5. So that's going to actually help me a lot because now I've got smaller numbers that are going to be a lot easier to work with. So now I do the cross multiplying, and I've got 13 over 4 times, now 16, I know 16 is 4 times 4, right? Over 5. So 16 over 5, 16 over 5. That allows me to cancel out one of these 4s. Makes my life a whole lot easier. And then I've got p times 13 over 6. Okay, so now what I really have is 13 times 4 in the numerator here. And that's going to be 2, that's going to be 52, I think. Yeah, 52 over 5 is equal to 13 over 6 times p. So now, to get rid of this, I'm going to multiply by the inverse fraction. So these cancel each other, and these cancel each other because 13 times 6 is the same thing as 6 times 13. So it'd be 1 over 1, or it'd be 1p would be our answer, right? But if I do that on this side, I have to do it on this side. So 6 over 13. Okay. So I know for a fact, because I just did it, that 13 times 4 is 52. So I can rewrite this as 6 over 13 times 13 times 4 over 5 is equal to p, because this is all canceled. That allows me to cancel out that 13. 6 times 4 is 24, and the denominator is 5. And that is my solution. Okay? Canceling and reducing as you go makes your life so much easier. So do that as you go, and you won't have to deal with those really big numbers that can confuse you and mess you up. Let's look at the next one. All right, so here's the next problem. We need to find m and p, and we'll find m and p by filling out this table down here. So we have the big triangle, so this is our big one, and this is our little one, our little triangle. So big and little, and this is going to help us find our values. So we've got the side, that's going to be this. The big triangle is 5, and the little triangle is 4. The top, this is 9, and this is m. And the base, in the big one it's 7, and the little one it is p. We've got to find m and p. So all we need to do is look at this in regards to the way it is set up. We need to have a fraction that has both numbers, and set that equal to a fraction that has a variable. So 9 over m, and we're going to use the same fraction, 5 over 4, equal to 7 over p. Okay, so we cross multiply. 5 times m is 5m, and 4 times 9 is 36. So when we divide both sides by 5, we get m is equal to 36 over 5. And when we do the same thing over here, we get 5p is equal to 28. So p is equal to 28 over 5. And those are your answers. So that's what you would put in here for m and p. You would put 36 over 5 and 28 over 5. That is the value that we're looking for. All right, let's look at the next problem. So here we're doing much the same thing. It's just that we didn't set it up in a table beforehand. You have to do your own table work here. So again, we've got a big triangle and a little triangle. So our little triangle, it's listed first. So let's put it over the top and do our big triangle on the bottom. So we have, this is 2 and 1, 2 and 1. So let's give these angles a name so it's a lot easier to find them. Let's call this X, Y, and Z, and you can name it any letters you want for the sake of keeping up with it. So side XY, all right, that's going to be, the little triangle is 8, big triangle is 12. Side YZ, you've got in the little triangle that's M, and in the big triangle that's 10. And then you have side XZ, little triangle that's 5, big triangle that's Q. So we take the one that has two numbers, 8 over 12, set that equal to M over 10, and the same fraction equal to 5 over Q. So again, remember I said you can reduce to make life easier on yourself. This is going to be 2/3. So 2 over 3 is equal to M over 10. And 2 over 3 is equal to 5 over Q. That's going to make life a lot easier just by reducing that. So we've got 20 is equal to 3M. So 20 over 3 is equal to M. And then we've got 2Q is equal to 15. So Q is equal to 15 divided by 2. Those are your answers. You do not have to divide them. You can leave them in fraction form. So M is going to be 20 over 3. And Q is going to be 15 over 2. You do not have to divide them. In fact, leave them like that because that's the answer the way it's put in the system. You don't have to go to a decimal. Let's look at the next problem. All right, so again, similar triangles. So we have to give the triangles a name and kind of give some type of adjustment. So we know this triangle or this angle is congruent to this angle. This angle is congruent to this angle, which means by definition, this angle has to be congruent to this angle, right? So let's call this the big triangle and the little triangle, right? So we're going to give them letters A, B, C, A, B, C. And notice how angle with one tick mark is angle with one tick mark. That's the same letter, so they correspond. So let's do the big triangle on top and the little triangle on the bottom. So for side AB, the big triangle is 5. Little triangle is Y. For side AC, the big triangle is 10. And the little triangle is 14. And then in the side BC, the big triangle is 7 and the little triangle is X. So we find the one that has both numbers. So we have 10 over 14 is equal to 5 over y, and 10 over 14 is equal to 7 over x. And then we just cross multiply and solve for the variable we need to solve for. So that's going to be 10y is equal to 70. So y is equal to 7, because 70 divided by 10 is 7. And then we have 10x is equal to 14 times 7. What is 14 times 7? 70 plus 28, so 98. 14 times 7. Yeah, 98. All right, 98. So x is equal to 98 divided by 10. Those are your solutions. Those are your solutions. Now you can actually reduce this fraction. So that would be x is equal to 49 over 5. And then y is equal to 7. So 49 over 5 and y is equal to 7. Just like that. All right, and it doesn't matter, honestly, if this is the big triangle or this is the little triangle. You could call this triangle left triangle and right triangle, honestly. As long as you know you organize the dimensions for this triangle on the same row and the dimensions for this triangle on the same row. That's the important part. So what you call it doesn't matter. The labels that you give each angle doesn't matter. As long as you organize your data with the same triangle measurements on the same row and then the same sides together. Then you can see the one that has both numbers and pair it with each of the ones that has a variable. Cross multiply and solve. That's what we're doing every single time. Okay, let's look at some more of these. So again, we've got mixed numbers that we need to get rid of. So 3 times 2 plus 1, that's going to be 6, 7. 7 over 3 divided by 7 over 10 is equal to 6 over x. So if it throws you off that you've got fractions over here and whole numbers over here in each of the numerator and the denominator, just turn these into fractions. We know we can turn a whole number into a fraction by putting it over 1. Now you have fraction, 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 fraction. So now you have 7 over 3 times x over 1 is equal to 7 over 10 times 6 over 1. So now you have it where you can see it. Now, one of the things that I know is that 10 is going to be 2 times 5, and 6 is going to be 2 times 3. So I can eliminate the 2. So now I have 7 over 3 times x is equal to 7 over 5 times 3 over 1, right? So the reason I'm not going ahead and multiplying that is because I know that I've got to multiply this whole thing, 7 over 3 times x. I've got to multiply this by the reciprocal, or not reciprocal, the inverse. Well, it is the reciprocal. It's the inverse fraction. So 3 over 7 times this side, and I've got to do it on this side too. So 3 over 7. That allows me to cancel my 7s before I do any math and then have to undo it and factor it back out. So then these 7s are canceled, these 3s are canceled. I just have an x over here, and I have 3 times 3 in the numerator, which is 9, and 5 times 1 in the denominator, which is 5. And that was so much easier than trying to multiply it and then reduce it later. But that is the correct answer, 9 over 5. So I hope you see how it doesn't matter if it's a fraction. If it bothers you that it's a fraction, turn the others into fractions. and it makes life a little bit easier. Just put them over 1, and then they're in the same format. And don't necessarily be quick to go ahead and multiply. Hold back a little bit and just factor things out so that you can see what cancels, right? If you hold off on that step of multiplication and just wait and see what happens. And then once you wait and see what happens, then you can reduce it much more readily. And then you can do the math in your head. Instead of saying 21 over 5 times 3 over 7, oh wait, undo this and reduce it by 7. You won't have to do that if you just leave it unmultiplied until you get all the factors that have to happen there, and then you can reduce it and cancel it out. Let's look at another one. Okay, I do want to say this one thing. Where is your sister? She knows how to do this. She could be helping you with this stuff. She's a smart girl. Does she not like helping you with math? Because she could do it. You need to fuss at her and say, sis, I need help. You're supposed to be helping me because you're supposed to love me. So get over here. Okay, that being said, I enjoy helping you. I'm not trying to get out of anything. I'm just saying sisterly love, right? All right, so 21 times 4, that's going to be 84. Ooh, my head hurts now. 84 plus 12, that's going to be 96. So remember when I said you don't necessarily have to multiply everything, right? That's true. That's very true. So 84 plus 12, that's 96. So we'll rewrite that as 96 over 21. And then this is 7 times 2 is 14 plus 6 is going to be 20 over 7. 3 times 4 is 12, 13, 14 over 3. And then we have x over 1. So now we have fraction over fraction equals fraction over fraction. We can deal with this. 20 over 7 times x. We don't need to put the plus 1. We know that. And then we've got 96 over 21 times 14 over 3. Can we reduce this? Those are really big numbers. So let's look at, before we put this 14 over 3, let's move it over. Let's see if we can factor this out up here somewhere. All right, so 96 over 21 is equal to what? Can we get, I think we can get 3 out of here. So that would be 32. 3 times 32. And then we could get 21 is 3 times 7. And then 32 is going to be 2 times 16. So let's do that. Times 2 times 16, right? Okay, so instead of writing 96 over 21, we're going to write its factors. 3 times 2 times 16, and that's as far as I'm willing to go right now. And then 3 times 7. And then we've got 14 over 3, right? Now we've got this, because we're multiplying by that. We know this is 2 times 7, and this is just 3. So right away, we can get rid of the 3's, and we can get rid of the 7's. That's really all we can get rid of. So 20 over 7x is equal to 2 times 2, that's 4 times 16. I'm not going to multiply it just yet, over 3. Let's just leave it like this until we can figure out what we need to do. I know that 4 times 16 is 64. We'll just leave it for the time being because 20 over 7, we want to get rid of this we're going to multiply by 7 over 20. Right? Now this would cancel. So all we have here is x. But when I multiply from this side over here, I've got to flip it. Well, no, I've already flipped it. So I've got to come over here and say 7 over 20, right? Well, guess what? 20 is 4 times 5. So the 4's cancel. That's why I didn't go ahead and multiply it. Because I knew that I could probably factor something out if I just paid attention to what I was doing. Now, 16 is 4 times 4. That's neither one of these, so I can't factor anything else out there. And 7 is prime. I can't factor anything else out here. So now I know that this is at the point where I need to multiply it. So 16 times 7, that's going to be 112. And then 3 times 5 is 15. That's your solution. And you leave it just like that. 112 over 15. So think about waiting to multiply until the very end. Factor and cancel as much as possible during the problem so that you don't have these big, huge numbers that you then have to reduce at the end. It'll save you a lot of steps. All right, let's look at another problem so I can illustrate that a little bit better for you. All right, so good news. This problem that we just solved is also the exact same problem here. So that problem got put in there twice. I'm not sure how, but all you have to do is type that answer in 2 times and you're good to go. So you only had to solve it once and you get 2 points for it. So maybe that's what I was doing. I don't know, because it is a difficult problem. But you get double credit for solving it once. Moving on to the next problem though. So here we've got a base of a right solid. I think this is the point in which you have not solved. Have you solved any of these? You did not solve this one. I'm not sure why you did not solve this one. Okay, so you've got the base of a right solid. This is the base, which is this shape right here. And it's also the back of this shape right here. We need to find the volume. So how do we find volume? Do you remember? All right, so let me take this across and we will do this in our drawing program. Okay, so volume is what we're looking for here. Volume. What is volume? It is the area of the base times the height, aka or length. It's that 2 dimensions, you got 2 dimensions here, times that 3rd dimension, right? So area we know is something times something. You've got A times B, and then this 3rd dimension here is C. So A times B for area, and then you take the area times the height or the length. That's that 3rd dimension that gives you volume. So our area is this. This is our area of the base. And then this is going to be our length or our height, depending on whether it's sitting on the base or it's laying on its side. In this case, it's laying on its side. The prism has been knocked over and it's laying on its back. So the base is showing it's turned up. Don't let that, mess you up. This is the back. That's all that's happening here, is that this matches this. It just got flipped over on its back. You gotta learn how to really look at these pictures and see what's happening here. All right, so area of the base. Here is our area of the base. There's 2 ways we can look at this. We could look at it like this, as if this were a triangle, but then we would not have this dimension here. And we wouldn't necessarily know where this stops and starts on the 34. We're not given anything that divides it here. But we are given something, a dimension that divides it right here. So what we need to do is cut this off as a triangle across the top, and then treat everything down here as a rectangle across the bottom. So we have 34 by 6 here, and then because this is 16, this base has got to be 18, because 18 plus 16 is 34. So this one is going to be 20 by 18 divided by 2. So the triangle for the area of the base, 20 centimeters times 18 centimeters divided by 2, because it's a triangle, is going to be 180 centimeters square. Now we have the rectangle, which is 34 centimeters times 6 centimeters. And good Lord, that's a large number. I think it's 204. Let me double check. 34 times 6, 204. Look at there, I guessed right. 204 centimeters square. We add those two together. 384 centimeters square. That is the area of the base. So that is what we have right there. So now for volume, all we have to do is say 384 centimeters square times the height here, 20 centimeters. So calculators please, because that's a really big number. 384 times 20, 7,680 centimeters, 2 times, a third time, cubed. That would be your answer. Girl, you got to put some thought into it, break it down, okay? Draw on the shape. Do what makes the most sense so that you can actually have figures that you can calculate. Remember your formulas, right? Area of the base times height or length. It doesn't matter what we call it. It's that other dimension that is not included in the area of the base. So this length here. Okay. All right, so we're back to one of those proportion problems. That's what's next. Okay, here we go. So again, turn mixed numbers into improper fractions. 16 plus 3, that's 19 over 4 over 8 over 9. Notice I like to make that middle line a lot bigger so I can really distinguish it when I write it down. That helps too. It's just all about organization of your problem so you can clearly see what's going on. 9 times 2 is 18, plus 1 is 19, over 9, over x. And we'll turn that into a fraction just to make life easier on everybody. So we've got 19 over 4 times x over 1 is equal to 8 over 9 times 19 over 9. Okay, well, I don't know about you, but I don't see anything that I can reduce by. 19 is a prime number. Both of these have factors that are 3. This is a factor that's 2. I can't really reduce anything here, but I know that in order to get x by itself, I've got to multiply by the reciprocal here. So I'm going to go 4 over 19. And then I'm going to go 4 over 19. You see what I see? The 19s get factored out, which is great because that's a really big number. So the 4's get factored out, 19's get factored out. We have x is equal to 8 times 4, that's going to be 32, over 9 times 9, which is 81. That's your answer. 32 over 81. And holding off, right, not multiplying until the very end, allowed me to cancel. So I really didn't have that many steps. It was really just about rewriting it with mixed numbers and then putting all of my factors out in one place. It makes life a lot easier. So think about that hesitation. Sometimes that hesitation to complete the calculation is more useful than actually completing the calculation and before moving on to the next step. Work smarter, not harder. Think it through. Okay, looks like, let's see, you got the next one with the Holsteins and the cows, and you got the thespians and the mathematicians. You got all of those. Looks like it's the very last one. It is the very last one that you have gotten stuck on. So let's do the very last one. Okay, so here the hikers slogged that particular problem. That's the one we're going to do. That's the one you got stuck answering. Okay, so the hikers slogged 10 miles through the muck in 5 hours. So that is a ratio. You've got 10 miles in 5 hours. There's your first ratio. Then they came to the pavement and were able to triple their rate. So their next rate, how long would it take them to cover 24 miles on pavement? So now their pavement rate is times 3 over 1. So now they can go 30 miles in 5 hours. Okay? Because triple is times 3. That's a whole number. We can reduce this 6 over 1 because we divide this by 5, we get 6. We divide this by 5, we get 1. So 6 miles per 1 hour is their new rate. That's their pavement rate. So they've got 24 miles. So we need to turn that into hours. We're going to convert that into hours by using our new rate. So we flip that around so that we can cancel out the number of miles. I wrote that in the wrong spot. So it's going to be 1 hour over 6 miles because it's the same thing, remember? 6 miles is equal to 1 hour. That's what we're doing. So we just flip it around so we can do a unit conversion. So we cancel the miles. That ends up being 24 divided by 6, and the unit of measure now is going to be hours. 24 divided by 6, that's going to equal 4 hours. So 4 is the number that goes in here. Take the time to think it through, okay? You could have even started by saying, oh, they're doing 2 miles for 1 hour, right? You could have reduced this fraction in the front. 10 over 5 is equal to 2 over 1. And if I triple that, so that's times 3 over 1, then that's 6 over 1. You could have reduced it at the beginning instead of at the end. You still got the same rate if you did it that way. All right, so I hope that helps you think about how to do these problems a little bit better. It's just a unit conversion, just like we've always done. We're just canceling different things now. We're combining distance and time into one fraction so that we can convert. And then when we're just given one or the other, that becomes our number over 1. And we use our unit of reference to convert it to what we need to convert it to. Okay, I hope I didn't confuse you. I will see you in class tomorrow. I hope this really helps you a lot. Bye for now, and I hope you got everything you wanted for Christmas. See you tomorrow. Bye.